Welcome back. Now that we understand how to work with the basics of NumPy arrays, let's quickly talk about what an image actually is. So before we talk about how to use NumPy specifically with image files, let's first discuss how computers themselves handle images. Let's imagine that we wanted to build software that could sort out mail based on the zip code of the address written on the envelope. Often mail is handwritten, which means we would somehow need to begin to understand how to use computer vision to actually read in image data of these handwritten digits. So most likely we're going to be working with an image such as a photograph of the envelope, like a PNG or JPEG, and we want to understand how does a computer actually represent image data. Let's imagine we have a simple image of a handwritten number. So here we have images of the numbers 1, 2, and 3, and these are either JPEG or PNG files. Each single digit image can be actually represented as an array. So here we have the numbers 0 through 9, and these are all being represented as an array. So for example, here is a number represented by 28 by 28 pixels. You can imagine that as we get more and more pixels, we'll have finer and finer resolution. You'll also notice that the image on the left is grayscale, meaning it's only black or white or some color of gray, and it's being represented as an array with values ranging from 0 to 1. So how dark a pixel should be can be represented as those values between 0 and 1. So you'll notice here we have a number 1 as the handwritten digit, and where it's darkest, it's represented as a single digit 1, and where it's completely white, it's represented as 0. Now, often default images, when you actually read them in, they have values between 0 and 255, where 255 is the highest or brightest value, and 0 is the darkest. The range 0 to 255, that actually has to do with how computers store 8-bit numbers. That's a bit outside the scope of this course, and we really don't need to understand it, but at the end, I'll show you a couple links that you can check out for more information. Now, if you ever wanted to get those values between 0 and 255 to be between 0 and 1, all you would need to do is divide by the max value, 255, in order to normalize to between 0 and 1. And later on in the course, we'll see some examples of doing that. So we've understood how grayscale images can be represented as arrays, but what about color images? Color images can be represented as a combination of red, green, and blue. Additive color mixing allows us to represent a wide variety of colors by simply combining different amounts of RGB, or red, green, blue. And RGB allows us to produce a range of colors. And here we can see the entire dynamic range that just red, green, and blue allows you to create. This sort of image is known as a color triangle, and basically what that means is only colors within this triangle can be reproduced by mixing the primary colors, that is red, green, and blue. Colors outside the color triangle are therefore shown here as gray. And the primaries and the D65, that point in the middle, that's the white point, and basically shows you the edges of what's producible. And keep in mind that humans themselves have limits as far as what colors they can see. But obviously red, green, and blue allows for quite a wide range. Later on in the course, we're going to be learning about alternative color mappings that can be applied to images that go beyond just red, green, and blue. But for now, red, green, and blue will be more than enough for us. So each color channel will have intensity values. And you may have already seen this sort of representation in other software with RGB sliders. In fact, you can just Google RGB slider to play around with these sort of values. So here you can play around with the values of red, green, and blue to produce different colors, all the way values from 0 to 255. So what does that actually mean when you read in a color image with Python and a computer in general? So what happens is when you read in an image, it's going to actually have 3 dimensions, a height dimension, a width dimension, and then 3 dimensions for these color channels, red, green, and blue. So this means that you're reading in the image, and if you were to check its shape, if you read it in as a NumPy array, the shape is going to be something like 1280 by 720 by 3. So that would be the pixel width, the pixel height, and then the actual 3 color channels. So if we were to actually visualize this, basically you have a 3-dimensional array where we have the typical 2 dimensions, except now you have 3 of those, 1 for each major color. Keep in mind the computer itself won't know that a channel is red. It just knows that there are now 3 intensity channels, essentially 3 sort of grayscale channels representing a color. So notice that when the computer actually reads it in, it gets something that looks like this last column here, black and white. It's up to whatever software you're using to actually represent those as color in order to combine them to get that left image all the way on the left where we have the parrot. So keep in mind, we're still getting values between 0 and 255. It's just now we have 3 of those mappings, one for red, one for green, and one for blue. So the user needs to dictate which channel is for which color. Each channel alone is essentially the same as a single grayscale image. So let's explore this further with NumPy and Python. I also highly encourage you to check out the Wikipedia article on RGB color channeling. It's called RGB Color Model, and it has a lot of interesting details as well as the history of RGB Color Model and a couple of more fun things to play around with. Okay, so let's move on and explore this further with NumPy and Python. I'll see you at the next lecture.